Okay, so let's start with this arrangement of the word jewelry. Okay, and when we see this kind of words, we break down into their alphabets first. So J, E, W, E, L, L, E, R, Y. When you break it down, just continue to check that every column you really have got a different alphabet, okay, just to be careful. So better for you to also be careful and write down the total number of letters first. So in this case, we have got 9 letters in total, and the distinct number of letters here is 6. And distinct means different. So altogether, we have 6 different letters. Okay, so let's start with part 1. Part 1 says, I want to have no restrictions on the arrangement. We're going to use all alphabets, so in total you have got 9 alphabets. It will be 9 factorial, and we divide by the repeating letters. There are 3 E's and 2 L's, so it will be a 3 factorial and 2 factorial. 2, I would like my arrangement to start from L, and between any 2 E's, I would like to have at least 2 other letters. If you're not sure on what the letter or the word will look like, we will always try to write down certain examples just to understand the problem. So they are using already 1 L, and their requirement is between any 2 E's. We just look here first that there is 1 L, 2 L's, and altogether 3 E's. The starting position must be L. And between any E's, then we put in other alphabets. So can we try to draw out how it may look like? Let's draw out one case first. We must start from L. So let's say you've got 1 E. Before you can write another E, there must be a minimum of 2 spaces. Okay, let's just assume it's 2 spaces so that we can think about what the case will look like. We then see how many balanced letters there are. If I take away 1 L and 3 E's, I will have 5 letters left. Okay, J, W, L, R, Y are left over. So we plan through. If you can have 2 spaces, then E, I can have another 3 space also, then we get another E. And no more other spaces. The spaces I'm placing are referring to your J, W, L, R, Y. Okay, those spaces we will put in these red color letters. So this is one possible case. We try to systematically list down other possible cases also. We can do a mirror image of the spaces. So I don't want 2 and then 3. We could go for E first, 3 blanks, another E. Okay, we flip it, the mirror image, and then 2 blanks with another E. So are there any other possible cases? It doesn't need to be 3 blanks. They are just saying at least 2. So it could be 2 blanks always. E, 2 blanks with another E, followed by the same thing. And the last letter is a blank, which is one of the red color alphabets. And lastly, we go for the mirror image. So it will look like this. So in this kind of question, we are trying to systematically list down everything if it's not too long. There are 4 cases. How do we calculate for each case? Actually, per case, you're just going to do 5 factorial. This is to permute your J, W, L, R, Y. Their positions for L and E's are fixed, so don't need to move them. And this is for all 4 cases. We're going to do the same thing. So we just do 5 factorial times 4. Okay, every case we do the same. We fill in the blanks with your J, W, L, R. Now 3 and 4, let's look at both phrases together first. All not together versus not all together. Okay, what is the difference? All not together just means you break it up this way. Always break up between the word all and not. Next one similar. Break it up between all and not. So first one actually means I want all vowels separated. View that word not together as separated. All of them separated. Okay, let me do for that part first. Okay, work out part 3. How do we do a separation problem? If we want to permute the rest first, what are your vowels? Your vowels are the 3 E's. So I will have remaining J, W, L, L, R, Y. This is the balance. You don't want vowels together, you're going to slot in the vowels. So that's the concept here. You have 6 letters, it will generate 7 slots for you to slot in. So the number of ways will be, we permute the top row first, always permute the remaining items that you want to permute, that you want to put in. Okay, so J, W, L, L, R, Y, we permute 6 factorial over 2 factorial. You slot in, if you have 6 objects, there will be 7 slots. So 7 choose 3. If you want to permute the E's, you write 3 factorial, but it's repeating letters anyway. Okay, so this is not necessary, it's optional. This is 1. Okay, basically you are permuting the remaining. This is your remaining. And this is your number of slots. 7 choose 3. Okay, next. What about if the word not comes in front? Not first, followed by that phrase altogether. So if that word not comes first, it means to exclude. Exclude all vowels together. If that first word is not, okay, then it is to exclude. I want to exclude all vowels together, meaning you think of this like a complement method. Everything else you want, you just don't want all the vowels to be together. So go for complement. Let me just put it here to write down. Okay, so in part 4, I don't want all the E's to be together, so we are going to go for no restrictions. Subtract all E together. No restrictions, we found it in part 1. Minus away all E's together. So if it's all E's together, force them into one group. The rest are outside, J, W, L, L, R, Y. So count this as one group. Altogether, we have got here as 7 groups. Okay, so this will be 7 factorial. And divide by the repeating L's below. In that 7 groups, there are 2 that are the same. Okay, so this is to illustrate how to group objects together, force them to one group. No need to permute the 3 E's because they're exactly the same. Okay, last case, I would like to form a 4-letter code word now. Find the number of 4-letter code words that can be formed. When we do a shorter code word problem, what I will typically do will be, can we write down all the cases first for the 4 letters? And I write in based on the structure. So the 4 letters could look like it is A, B, C, D. Okay, so it's just random letters to illustrate the structure. I don't want to write in words like 4 distinct letters because it might be hard for you to phrase later on. So this is one possible case. Another case could be, say, A, B, C, where you have 2 letters in front that are the same. Or A, B, B. And last, it could be all 3 the same before a different letter. Okay, so no other possible structures that we can have. These are the 4 cases. So let's start from part 1. Generally, you want to choose the letters first, then you permute. So we decide on the letters first. So if it's A, B, C, D, 4 different ones, choose from distinct, never choose from the total, must choose from different ones. So must be 6 choose 4 and not 9 choose 4. Always choose from distinct in this chapter. and you permute the 4 letters that you have, 6 choose 4 and 4 factorial. Now, if it's 2 A's, the A must be specific from either E or L. Only E or L has got more than 1. So we choose for the A first because that's the special one. We go for to choose one, either E or L. So once you have removed one alphabet, total you have 6 different ones. So now we are left with 5 to choose for the B and C. We choose one from EL, the balance can be to B and C, so we have 5 left, choose 2, and you permute the 4 objects with a repetition at the A. Okay, AABB must be the format with EELL. No other letters are twice or 3 times, so must be EELL. So it's fixed. You don't need to choose the E's or L's. We just need to permute. I already know must be 2E, 2L. Okay, no other possibilities. Okay, so no choosing required, must be EELL. Okay, so maybe I address one question first. For the EE, some of you may then ask, do we need, okay, do we do 3 choose 2? Because you have got 3 E's, you want to have 2 E's. Some of you may do that, 3C2. Okay, so answer is no, because the E's are not distinct. Okay, so be very careful in the whole chapter. When you want to do N choose R, you must ensure that the N are distinct. Okay, if not, you don't choose. Okay, last case, this 3 A's must surely be E. So I only need to pick for the B. So 5 choose 1 to pick the B, one balanced letter. And we permute all 4 of them, 4 factorial over 3 factorial.